Hello class, and welcome back to Sketch Science. This is our ASMR portion of Kinetic and Potential Energy, Part 2. Now, what do we remember about kinetic and potential energy from the last one? Maybe you'll remember that potential was the energy of position. It's where you're at, not what you're doing. And kinetic is what you're doing, not where you're at. It's motion-based. So, just think about those for a second while we go into what we... Okay, I can't do this anymore. We're going back into kinetic and potential energy, and we're talking about what happens to an object as it goes from one to the other and back again. What could happen? Or maybe, what if you got a question and they gave you the energy in some things, but they were missing something like the weight or the speed? How could you find those? Well, in this scenario, we're going to be looking at this U shape. Keep in mind that this side is higher than this side. The left is higher than the right. So, if you have ball A here, ball B here, ball C, ball D, and ball E, assuming it travels down this way and up that way, that's the direction the ball's moving. What would you be able to gather from this? Well, maybe which ball has the most potential energy? Which one would have the most potential energy? Maybe the car that's going outside does. But in this case, the most potential would be A, because it's the highest off the ground. It is higher than any other ball here. Well, what about the least potential? Well, the least potential would be your ball C, because ball C is at the very bottom of the ramp. No other ball is lower than it is. It is at the bottom of the half pipe. But because of that, what would it have? It would have the most kinetic energy. Most kinetic would be C, because it's at the bottom. It's moving real fast. Nothing's slowing it down yet. It just hit the peak, the bottom of the ramp. There's no more potential to go into it. All it has to do is keep going until it hits the ramp and starts slowing down again. But at that moment, it's going super fast. It is Sonic the Hedgehog down there. Number C, letter C, ball C, whatever you want to call it. It is going fast. Well, which one would have the least kinetic energy? Assuming A is already rolling. So if you assume A is already rolling a little bit this way, which one would have the least kinetic? And for that, I would say E. I would say E would have the least kinetic because A, it's rolling a little bit. It's getting it going. It's getting that potential rolling into kinetic. It's doing its thing. And as it falls, B's going faster, C's going super fast, and then D's starting to slow down, and E's hitting the top of the other hill, and it's just trying to cling on to any motion if it has any left at all. E could be stopped for all we know at this point and about to roll back down. So, that's how you figure out which one is which one has the most kinetic, most potential. Remember, it's all about position for potential. A is at the highest point. It has the most potential. C is at the lowest point. It's got the least. Kinetic's about motion. It's getting it moving. It's doing the grooving. It's doing what it wants. When it wants, it's going fast. And A's not going too fast. E sure is not going too fast because it's reaching the end of the hill. It's run out of energy. Meanwhile, B and D, B's going, it's all right. It's going downhill. It's having fun, but it's not going too fast yet. And D's kind of slowing down. It's going that grind back up the hill. But C's a free ball. It's going everywhere it wants, when it wants. It's going fast. So, now that we went over that and a little picture of how kinetic and potential works and how it transitions from one to the other, what would happen in a potential energy situation if you had how much energy it had, how much they weighed, and of course, you've got gravity. So let's go back to our little spork knife game and talk about the person who built the ramp. this ramp going up. They're standing on the top of it, right? They're having fun up there, but what would happen? We don't know how tall that ramp is. It might be different from the last one, even if it's the same amount of levels. It's a different height. That's what we're going with here. But we know for a fact that they weigh 55 kilograms. And we know for a fact that gravity is 9.8 meters per second squared. And we know for a fact now, because I'm giving it to us, that their energy here is 21,560 joules. That's their potential energy. Well, if that's the case, how high off the ground are they? How high is this distance? Well, if you remember, potential energy is mass times height times gravity. So if your 21,560 equals 55 times 9.8 times n, we have to find that n. How do we find that? Well, it's actually easy here. It's a little bit of algebra. All you have to do to get n by itself is divide by the other two. So if you were to divide this whole side over here by 55 times 9.8, get rid of both of those. These two cross off, and you're left with n alone. And on this side, you also have to divide by that 55 times 9.8, which leaves you with what? If you have n equals 21,560 divided by 55 times 9.8, you would end up with, and I'll let you get a calculator for like 5 seconds. You can always pause the video if you want to. 4, 3, 2, and 1. The answer is they are actually 40 meters off the ground. That's how you would find it, is you take the same formula, you just got to find whatever thing is left over, and I could have actually left as an h for height. You can find that by having any one of the numbers. As long as only one of them's missing, you can easily find it by using all of the other ones you have. Now, it works the same way with kinetic energy. Kinetic energy, on the other hand, is a little bit different. It's got some exponents and different things in there. It's got that square. So let's go back to our van that we were talking about last time. So our van over here, we're going to add a driver this time. So our van over here, we don't know its weight anymore. Remember we talked about the weight last time. We don't know the weight this time. We do know it has a force of 200,000 joules. We know that it's moving 20 meters per second. We know that the formula for kinetic energy is 1/2 times mass times velocity squared. Well, how would you plug this into a scenario to get the answer? Well, I would start with 200,000 because that's your kinetic energy, and that equals 1/2 times your mass, that's what we're looking for, times your 20 meters per second squared. So what would you do here to get m on its own? It's multiplied by two things again, just like the other. So why wouldn't you just divide this by 1/2 times 20 squared? These cross out, these cross out. Well, now you're left with mass on its own, but remember, you got to divide this side too by 1/2 and by 20 squared. If you do both of those things, and I'll let you have 10 seconds this time to do that because it's a little bit more complex, because you might have to square the 20 and do the other stuff, but you got m on its own, that's your mass. You have 200,000 divided by 1/2 times 20 squared. If you put that in a calculator, you will get 1,000 kilograms. If anyone noticed, that's the exact same example we used in part 1. It's the same way. This is just the problem backwards, working backwards to find one of the other things. That's algebra, that's physics. We went over more concepts last time, a little bit of the math. This time we went over concepts and the rest of the math. You can find any one of these variables, these letters, if you have all of the other ones. As long as you've got the others and you've got the formula, you can find any of them just by doing a little bit of algebra, balancing the sides, moving it here, there, everywhere, going as fast as ball C was in the earlier example. You will stride right through any worksheet you're given. Now, this was the remainder of potential and kinetic energy, going over a picture and going over an example of math, of you don't have just the energy to find, if you can use the energy to find something else. So as always, if you learned something or if you have any questions at all, please like the video, comment down below, and subscribe. Because if you do these things, 1, you won't miss videos, 2, you'll be able to find videos quicker when you want to see them, 3, you'll be able to come back to this video whenever you want, and I can answer your questions finally so that you will never be lost. So if you have any of these things, or if you enjoyed the video, please like, comment, and subscribe, and I will see you next time.